Happy Monday, class. I'm trying this capability for the first time, so if it seems a little clunky, I hope you'll bear with it. Today we'll be continuing with lesson 6.6 on inverse trigonometric functions, so here it goes. This is lesson 6.6, inverse trigonometric functions, part 2. So you remember the last time that we were talking, we introduced to you the idea that if we need to get an inverse function for the sine and cosine, we must restrict the domain of the original trigonometric function. So if f of x is equal to sine of x, we can only consider a domain of negative pi halves to pi halves, so that the inverse function will indeed be a function of inverse sine, where x is now a ratio between negative 1 and 1. Also, if g of x is equal to the cosine of x, we can only consider a domain of 0 to pi, so that the inverse of g of x is equal to the inverse of cosine of x, where x is now a ratio between negative 1 and 1. So you remember the last time that we met, I finished off with saying when you're thinking of the sine and its inverse, you need to be thinking about a domain for that sine of negative pi halves to pi halves. And when you are thinking of a cosine and its inverse, remember the domain must be restricted to 0 to pi. And the tangent also follows the lead of the sine, so that it follows having the same domain of negative pi halves to pi halves. So continuing, if we're evaluating inverse trig functions, we need to find the exact value. So let's take a look at that first one where it says arc cosine, but we remember that that's inverse cosine of root 2 over 2. So that's the ratio. This is the ratio that we have of root 2 over 2. And we know that when cosine is equal to root 2 over 2, we are talking about the cosine of pi fourths. So we're saying then that this is going to give us a value of an angle, and that value is going to be pi fourths. Likewise, if we're taking the inverse cosine of negative 1, well, we know that if we're talking about where is cosine equal to negative 1, cosine is equal to negative 1 at pi. So this is going to equal an angle value of pi. Let's see. Arctangent, remember arctangent is inverse tangent, so we could write that as tangent to the negative 1 of 0. We're asking ourselves, really, when is tangent equal to 0? Well, we know that tangent is equal to 0 when sine is equal to 0. And sine is equal to 0 at 0. So the inverse tangent of 0 is equal to 0. And then where is tangent equal to negative 1? So if we wanted to find the inverse tangent of the ratio negative 1, we have to consider when is that true. Well, tangent is equal to 1 when the opposite is equal to the adjacent. When is it equal to negative 1? Well, since we are talking about negative pi halves to pi halves, we have to say, well, tangent is equal to negative 1 when theta is equal to negative pi fourths. So the answer to when is inverse tangent equal to negative 1, that would be negative pi fourths. This next part, we're going to be using a calculator. I'm just using a scientific calculator this time. And you might want to remember that you need to, when you're seeing numbers like that negative 8.45, you want to be in radian mode and not in degree mode, because there isn't any degrees that we're dealing with here. And by the way, we are looking at a ratio. So let's go ahead and find the inverse tangent of negative 8.45. So I'm just going to go ahead and punch that into the calculator. negative 8.45, and then take the inverse tangent, and I get negative 1.4530. So that was taking the inverse tangent of negative 8.45 with the calculator set in radian mode. So that's an angle of negative 1.453 radians. Okay, let's do the inverse sine then. So 0.2447, we'll take the inverse sine of that, and we get 0.2472. And that's, once again, also in radians, so that's 0.2472 radians. So about a quarter of 1 is what that value is. And remember, pi is about 3.14, so this is 1/4 of 1, so that would be 1/4 of a third of pi. Okay, and then arc cosine of 2, or the inverse cosine of 2, should give us an error. And sure enough, if I put a 2 in and I take the inverse cosine, I get an error. And so we got does not exist. Here's an important note to consider. Keep in mind that these inverse properties do not apply for just any arbitrary value for x and y. And so, for instance, notice we have the inverse sine of the sine of 3 pi halves. And remember, we have to stay within negative pi halves to positive pi halves. 3 pi halves is outside that range. And so when we take the inverse sine then of negative 1, we get negative pi halves. So if we took the sine of 3 pi halves, you would end up with negative 1, and that's why you see the arc sine of negative 1, and we end up with that value, negative pi halves. And we don't get 3 pi halves, which is what you might expect to get, but you don't. So in other words, the property arc sine of the sine of y equals y is not valid for values of y that are outside of negative pi halves and pi halves. So here are some kinds of problems that you should be considering. In example 5 here, it says, if possible, find the exact value. So we're trying to take the tangent of the inverse tangent of negative 5. Well, it'd be nice to say we get negative 5, and actually we do. And the reason why is because you want to think about the fact that the domain of the inverse tangent function is negative infinity to positive infinity. So is it possible to get negative 5? Yes, it is. And so if you take the arctangent of negative 5, you get some angle, and you take the tangent of that angle, and it will give you negative 5. So for A, the tangent of arctangent of negative 5 is 5. Now, look at B. We've seen something like this before. We're trying to take now the sine of 5 pi thirds. Now, if you think about 5 pi thirds, we're in the fourth quadrant, and so we can think of that, but we have to think of it differently and not call it 5 pi thirds, because 5 pi thirds is coterminal with the angle negative pi thirds. So if you took the arc sine then of the sine of negative pi thirds, you would end up with the same answer. And so arc sine, let's see, we're taking that of a ratio, and we're expecting to get an angle. And so the angle ends up being, when we get the inverse sine of the sine of 5 pi thirds, we come up with negative pi thirds. Because remember, our answer has to be between negative pi halves and pi halves. And negative pi thirds is the right answer for that one. Now in C, we're taking the cosine of the inverse cosine of pi. Now we have to be taking we have to keep in consideration that the cosine has the range that we consider from 0 to pi. And if we're taking the inverse sine of pi, we're actually having to maintain the fact that the range for inverse cosine is -1 to 1. I'm sorry, the domain of the inverse is -1 to 1. And pi is 3 and a little bit more. So it's outside that range. So the answer for C, it does not exist. We're going to get into some of the kinds of problems that you'll be doing in your homework where you're going to be seeing a composition of functions and their inverses. And so let's just take a look at problem part A of example 6 here, and we're looking now at the tangent of the inverse cosine of the ratio 2 over 3. Now think about that for a second. We're talking about the cosine is equal to 2 over 3, and so if that's the case, then the adjacent of the angle, and we're looking in the first quadrant here, the adjacent of the angle is 2, and the hypotenuse of the triangle in the first quadrant is 3. So if you use the Pythagorean theorem, you could actually look at where we have in figure 6.73 there, the square root of 3 squared minus 2 squared. That's 9 minus 4, that's 5, so we have the square root of 5 is the length of the opposite. And so now we're going to take the tangent. The tangent is the opposite over the adjacent, and you end up with an exact value now of the square root of 5 over 2. Now let's look at B. We're taking the cosine of the inverse sine of -3/5. So we're talking about a negative ratio for sine. And we know that sine is considering looking at negative pi halves to positive pi halves, and so we actually have to go into the fourth quadrant and actually refer to the angle as something that's negative. So we don't know what that angle is, but we do know that we can take the opposite, which is -3, and put it over the hypotenuse of 5. So if we do that now, we just draw our triangle, just like you see in figure 6.74, where the opposite is -3, the hypotenuse is 5, and so you can use Pythagoras again, and you see 25 minus 9, which is 16, and the square root of that turns into 4. So, and now what are we asking for? We're asking for the cosine. So the cosine is the adjacent over the hypotenuse. The adjacent is a positive 4, the hypotenuse is 5, and so the cosine of the arcsine of -3/5, or the cosine of the inverse sine of -3/5, turns out to be a positive 4/5. Okay, example 7. Notice it's titled Some Problems from Calculus. So this is a good problem to understand because this is the kind of stuff that you will see in calculus. And so I want you to notice as you just look at the part where it says write each of the following as an algebraic expression in x. A is saying what is the sine of the inverse cosine now of some ratio 3x. And they're saying, and consider x to be something from 0 to 1/3. Now think about that, because 3 times x is going to be 1 if x was equal to 1/3, because 3 times 1/3 is 1. And the ratio cannot be greater than 1 when we're talking about what is the ratio that I get, from any value of cosine in that case right there. So as you're looking at that, that's one thing to think about. And so that's why the range is what you see it is. I'm sorry, the domain is 0 to 1/3. So now take a look at figure 6.75, which is over to the right there, and you see that the angle then is really said to be the arc cosine of 3x. So you could call that 3x over 1, and so arc cosine means that we're talking about the adjacent, which is 3x over 1. And then the opposite then is the square root of 1 minus 3x squared. So as you look at that then, you're taking the cosine. You know that the cosine is 3x over 1. And so take a look down in the solution there. It says that now if we take the sine of that, the sine ends up being the square root of 1 minus 9x squared over 1. But you don't have to write the over 1 because it's just what it is. And then that's considering that x, the value of x, is just going to be anything from 0 to 1/3. Now the second part of example 7 is B, and it says, what is the cotangent of the inverse cosine of 3x? Well, we did the inverse cosine of 3x already, and that's what gave us our adjacent side of 3x and the hypotenuse of 1. And so we're still able to use that figure 6.75, where the opposite length is the square root of 1 minus the quantity 3x squared. So there's that. And so now when you're taking the cotangent, remember the cotangent is just the adjacent over the opposite. So if you look at the bottom of this example in its solution, B says the cotangent of the inverse cosine of 3x is the cotangent of that angle. And since we have that angle drawn in the triangle, and we've identified the adjacent, which is 3x, and we can put it over the opposite, which is the square root of 1 minus 3x squared. The only thing that changed was we changed that 3x squared to 9x squared because we just squared the 3 there. And still over the domain of 0 through 1/3. So similar arguments can be made. Down at the bottom says for x values lying in the interval negative 1/3 to 0, and that's just really saying that you know, you could consider that in a different quadrant and solve it that way. So I hope that this has been a helpful film for you to be able to watch. As a matter of fact, I'll make it available on my website so that you could watch it again. And I'm really excited about this because I think that I was able to create a lecture that you would have seen you know, me do in class, and really no different because you're seeing all the drawings that I've done, all the solutions that I provided, and that works. So here's the homework. Please look at pages 516 to 517. Do problems 37 through 67, all the odds, and then there's a couple of challenging problems there in number 75 and number 81. So good luck on doing that homework, and we will see you on Wednesday.